Welcome to AT Math Academy. Topic for today is polynomials. So we are taking two expressions and multiplying. So the expressions are 2x square plus 3x minus 6 is multiplied with 3x square plus 9x plus 2. So here the degree is 2. So this expression is called a quadratic expression. And here are two quadratic expressions, and whenever the two quadratic expressions are multiplied, I'll be getting the degree greater than 2. So such expressions are called polynomials. So for quadratic expressions, the degree is 2. So how you will do the multiplication is, I'm going to take each term from the first expression. Here are 3 terms. I'm going to take each term and multiply with every term in this second expression. So this is how you do it. So let's start by taking our first term from the first expression, which is 2x square. I'm going to multiply it with first term from the second expression, which is 3x square. And I'm going to take my second term from first expression, which is 3x, and second term from I need to multiply my first term with every term in the second expression. So 2x square is my first term, and I'm going to multiply it with 9x, and I'm going to take my first term again and I'm going to multiply it with constant. So I have completed multiplying my first term with all of the terms in the expression, second expression. Now I'm going forward with the second term. So it will be, the second term is 3x, so 3x multiplied with first term 3x square, and plus 3x is my second term, it is multiplied with this second term 9x, and I have one more term 2, I need to multiply it with 3x, so it will be plus 3x multiplied with 2, and my last term here is 6, so minus 6, I'm multiplying it with first term 3x square, and I'm again taking minus 6 and multiplying it with second term, which is 9x, and minus 6 multiplying it with 2. So now I'm going to apply my exponents, rules of the exponents, which is when the bases are same, a power m into a power n is a power m plus n. Whenever the bases are same and when we multiply it with different exponents, we need to add the exponents. So this is an exponential rule which I am applying. So 2 times 3 is 6. Here I have x square and x square. So base is same x. The exponents are 2 and 2. So I'm adding it here 2 plus 2. And plus. Here 2 times 9 is 18. And I'm going to add my exponents 2 and 1. So 2 plus 1. Here it will be 2 times 2 is 4 and x square. And here it will be 3 times 3 is 9 and x square. So x power 1 plus 2 plus 3 times 9 here is 27 and x power 1 plus 1. And here for 3 times 2 is 6 and x. Here minus 6 times 3 is 18 and I have x square. And 6 times 9 is 54 and I have the negative sign, so and x. Minus 6 times 2 is 12. Now 6 x power 2 plus 2 is x power 4 plus 18 x power 3 plus 4 x power 2 plus 9 x power 3 plus 27 x power 1 plus 1 is 2 plus 6x minus 18x square minus 54x minus 12. So now I am going to regroup. So for x power 4 I only have one value, which is x power 4, so which is the 6x power 4, only one value here. For x cube I have here 9x cube and 18x cube, and for x square here I have two values, which is 4x square and 27x square and 18x square. And for x I have two values, which is 6x and 54x, and here 2 is the constant value, so I can underline it with black. So now I am regrouping this. So for 6x power 4 I have only one value, which is 6x power 4, and for 18x cube, for x cube I have plus 18 and plus 9, so it should be 18 plus 9, which should be 9 plus 8 is 17 and 27, so it will be 27x cube. And after that we have x squares, which are 4, 27 and minus 18. So 4 and 27 are positive signs, so we can add those two. So 27 and 4, 7 plus 4 is 11 and 2 plus 1 is 3, 31. Plus 31 minus 18. So I need to subtract 18 from here. 11 minus 8 is 3 and 2 minus 1 is 1. So I'll be having plus 13x square. And going with x, plus 6x minus 54. So plus and minus, we are adding two different signs. We need to subtract it. So 54 is the negative sign and plus 6 is the positive sign. So when I subtract, my result would be with highest number sign, which is negative. So 54 minus 6 would be 14 minus 6, which will be 8, and here I have 4. So it will be minus 48x. Minus 48x. And for constant I only have minus 12. So this would be my final value after multiplying the two quadratic expressions. I will be getting this polynomial. This is called polynomial because the degrees are more than 2, and it also has more terms, more than one term. So one term expression is called monomial and two terms are called binomial. So this quadratic is 3 terms with degree 2, and anything higher than degree 2 with more number of terms is called polynomial. So this is how you solve the multiplication of the two quadratic expressions and get the polynomial expression. So while solving this, we need to take each term in the first expression and multiply it with all of the terms in the second equation. So 2x square is multiplied with every term, 3x square and 9x and 2. And 3x from the first term is multiplied with every term, 3x square, and 3x is multiplied with 9x from second term and it is multiplied with 2. Again, taking the constant value from the first expression is minus 6. It is multiplied with every term in the second expression, which is 3x square, 9x and 2. So when I am multiplying, I am going to apply my exponential rules. A power m into a power n is a power m plus n. So I have applied that. I have shown you here. And after my application of the exponential rules, I'll be left over with more number of terms with same degree. So I need to regroup and add and subtract the numbers depending upon the coefficients for the same groups, same degrees. So for the x power 4, I only have one term. For x cube, I have 18x cube and 9x cube. So it is positive signs. So I'm adding these two numbers. 18 plus 9 is 27. 4x square, 27x square minus 18x square. So plus 4 plus 27 is plus 31. minus 18 is 13. So 13x square. And for x cube I have 9. For x I have 6 and minus 54. So two different signs, I need to subtract it. So 54 minus 6 is 48, and I take the sign of highest number, so minus 48x, and the constant here is minus 12. So this is how you do it. Hope you all like my video, and please subscribe to AT Math Academy. Enjoy doing math at AT. Thank you all for your valuable time.